today we're looking at a Xevious board that does this. And if you can see that, you will see it says RAM OK, ROM 7 sound. So what's the first thing we do when we see something like this? Well, we look up the manual, because this is nice. It gives you it's giving you diagnostics here. We look up the manual what ROM 7 is, and it ends up being a chip, a ROM at 2C. Well, what do? If you have another one, just replace it. It's very rarely do I find actually EPROMs are the problem. So I replace it, it still gives me this error. So it's clearly not that. But there's another step we can take. We can take the Fluke, the EPROM out, put it in a EPROM reader and test it. And so let's take you through those steps now. So let's go ahead and open our EPROM reader program. And we're going to set the device to whatever the chip is. This is an AM2732A. But when reading, you can put any 27. You just put 2732. It doesn't matter. And now we're going to go ahead and read. We're going to save it to a file. Let's call it 2C. And then we're going to ROM ident, which is Hamster's ROM ident page, romident.coinopflorida.com. Click on the file, hit submit, and what we want is this Fluke signature, because we're going to use that when we need to verify the ROM. Okay, so now that you saw that the EPROM is okay outside of the circuit, the EPROM it's not the EPROM itself. It means that something's wrong on the PCB board. What's wrong, we don't know. So what can you do in this case? Well, let's take a look at this board. Okay? This board is insane. It's got 3 CPUs. 1, 2, which I don't have it in right now, and 3. And you're thinking this is from what, 1980, 81? 3 CPUs? You don't even have 3 CPUs in your desktop nowadays yet. Well, I mean, you can, but they're really expensive if you get multi-processor systems. But yeah, in the old days, you had a CPU that did, well, you might have a CPU that did the game code, one that had no graphics, and one that handled sound, just like Xevious here does, and Galaga does also. In fact, Xevious and Galaga are very similar. They're both by Namco, and they share the same basic design. So, what can we do? Well, I want to test the circuit from the CPU standpoint, because we tested this ROM and we saw that it worked fine outside of the circuit. So we want to actually read it from inside the circuit and see. And to do that, we have to understand a couple things. Because there are 3 CPUs on the Galaga system, or I'm sorry, the Xevious system, this is the main CPU right here, and this is the main game code. All the CPUs can actually reach the RAM, but they cannot actually reach each other's ROMs. So this guy can read these ROMs. This guy here can read this ROM. So we actually cannot plug into the main CPU. We have to plug into here. And we have to plug our Fluke into there and test that out. So let's do that. So we have the Fluke here. Okay, and you can see that I've actually plugged into that CPU. And I'm going to try to read, actually first we always do a bus test, right? And oh, already we have an issue. Controller error, 8 zeros, 1, and then 7 more zeros. If the CPU cannot get through a bus test, clearly that's an issue. There's no way if this test device CPU can can't pass the bus test, there's no way the game board's going to work. Because whatever's happening here is stopping the CPU from accessing the bus as it should. So what we need to do is take this off, go look at that error. I've never actually seen that error before, so I'm going to have to look at that in the Fluke manual. And we'll come back and test and see what's going on. So we saw that we had an error. It said, I think it's a controller error, and then it had 8 bits of 0, 1 bit of 1, and then 8 more bits of 0. And so we're going to head over to the Fluke manual to see what that means, because I've never seen that error before. And most of the information in the Fluke manual, this is the manual, Fluke 9010A Troubleshooter Manual. Most of the information, all the good stuff is in basically Chapter 4. And I think around 4H is where we're going to find that error. So I'm going to scroll down to here. Built-in tests, here we go. Bus test. Here we go. On page 4H2, control line not drivable. When you get a control error in the bus test, and then a bunch of bits loop. Note 1. In the binary 16-bit string, a bunch of B's, a 1 corresponds to an undrivable line, and a 0 corresponds to drivable lines. So the control line should be drivable. Refer to the appropriate interface pod manual for the control lines that correspond to the bit number. Extra bits are reported to 0. Okay, so we're going to have to go to the Z80 pod manual. So let's find that. So here we have the Z80 pod manual, and let's figure out what this is. This looks good. Status control line. So let's go to 3.3. And it looks like this is probably where we're fine. Where are they, though? Here we go. This looks like it. When performing a bus test and various other troubleshooter operations, the troubleshooter message controller error XXXX loop can occur, where X represents the binary number that identifies which lines can or cannot be driven. A binary 0 represents the ability to drive a line, while a binary 1 represents the inability to drive a line. Table 3.2 lists all control lines and their respective bit numbers. So let's jump to table 3.2. So control lines, and this was bit 7 memory request, okay? Because the high bit, it was bit 7, which is actually the 8th bit from the right. So looks like this is probably the M request line. So let's get the Z80. Actually, there's a manual picture of the Z80. M request is pin 19. So I'm going to go ahead and look at that pin on the processor and just make sure it's not tied to anything, that it shouldn't be like ground or +5. And it's very possible that I screwed up, because I actually all these sockets were so bad I desoldered the sockets and put new ones in. But we'll go to that chip and actually look at pin 19. I might actually pull it out, but we'll find out. So we're back. We're gonna pin 19 we found was problematic, right? Or that's what the message said, that this pin right here is having issues. So what I'm going to do is real carefully take this apart, take this board off, and just look at it to see what I can find. See if I can see any issues. Okay, so I have the board off here. I'm just going to quickly take my multimeter and make sure this thing is not stuck to ground or +5 or anything around it. Okay? So it's stuck to ground. I got a beep, but that's not, it's got a bunch of ohms between it. So, no. How about it's stuck to +5? Let's find a +5 in here. Where's a +5? Ah, stuck to +5. Not good. Why is it stuck to +5? I probably screwed something up. I'm going to go ahead and desolder this and see what I did wrong. So, I first looked at the schematics, and there's only one thing between MemRequest and, well, anything. It's an LS139 at 5E. And I traced, just for fun, oops, the wrong board. It's the bottom board. Just for fun, so it's this chip right here. 5E. And just for fun, I traced it along just to see if it, you know, if there was anything along the way that was bridged. I didn't see anything. So I'm going to go ahead and just pull this off because that's probably what's wrong. Okay. Now I'm going to go ahead and double check that again because now with that chip gone, if that chip was shorted, certainly I'm going to have continuity, but now I should not have any continuity. If I do, that means there is a bridge somewhere and there is no continuity. So that was it. It's got, well, hopefully that's got to be it. Let's go ahead and put another one. I'm going to put a socket in this and just put another chip in there. Actually, while we're at it, see if my chip tester detects this as being bad. Sometimes it does, sometimes it doesn't. When it says it's bad, it's almost always bad. Sometimes it says it's fine when it's not. Error. I don't know if you can see that there, but it's saying error. So this chip is most likely bad. So we have a new socket in there now. Put a new chip in there in 1 second. Test this chip to make sure it doesn't say bad, because sometimes once in a while you do actually get a bad new chip. All right, 139. Sounds good. And hopefully this will work. Put the CPU back in. And I know the video board works because that's a tested, known, good working video board. So hopefully, moment of truth. Come on, baby. Work for me. Oh, ROM 6. How wonderful. Well, that's better. Now we know something else is wrong. Great. So, I was about to go and start just writing up what I had information so far. Then I realized that the chip I had on here, the buffer chip, this is going to be the next ROM. The buffer chip here was not tested. I just grabbed this one from a pile where all the other ones are tested. And I figured, well, you know what? Since we never tested this one, we don't know it works. Let's throw this in, because this is a custom chip. Sometimes they go bad. Throw a known working good one on, and sure enough, I put a new buffer chip in there, and what we have now is game boots. Now, you'll notice here it says credit FF, and it won't actually coin up or anything. That's because this chip right here is missing. This is another custom chip that I don't have an extra of. I had to use that. I had to pull this one for another repair for somebody else, and I just don't have any more. So, you know, there you go. But we know this board now works, so I'm just going to update that to works missing custom chip.